All right, good morning, everyone. Welcome to the first session for GSUK. This is diving into zOS open source development and overview with Igor Todorovsky. You are in session 4A. This is part of the Open Mainframe Project stream. And if you have questions, feel free to either put them in the chat or to take yourself off of mute and ask the questions. Igor and Haritha are both here and they're happy to answer your questions. Don't forget to fill out your feedback link on the agenda abstract page or from your BYOA agenda. You should try to do those immediately after the session. They want me to explain that the best answer for question 1 is 5 rather than 9. And Igor will upload his slides after the session is over, so you'll be able to download those slides. So everyone, please help me in welcoming Igor Todorovsky.
All right. Hi, everyone. Thank you, Donna, for the introduction. Good morning, everyone in the UK, and good afternoon, good evening to everyone else who's joining us virtually. So today we're going to take you on our journey of how we're transforming zOS open source through the relatively new open mainframe project known as the zOpen Community Initiative. In particular, we're going to discuss how you can take part of that transformation, as our focus today will be on open source development for zOS through the lens of the zOpen community. So my name is Igor Todorovsky. I'm the zOpen community development lead, and I'm also joined by my colleague here today, Haritha D. She's also a lead developer for the zOpen community. And Haritha today will be demonstrating how you can actually port a particular tool from open source to zOS. And she's going to be doing a demo today. So first, we're going to start off with some background information, and then we'll take you through the step-by-step process of how you can get involved in porting to zOS. So before we dive into zOS open source development and importing, I would just wanted to take a step back and talk to you about an initiative called the zOpen Community and how it also relates to open source development on zOS. So the zOpen Community is an initiative that, again, is quite recent, started in 2022 with the intent of making zOS a first-class open source platform. We've gone quite a long ways since then. We now have over 200 plus open source projects that are available in our portfolio. And as of last year, October last year, we actually joined the Open Mainframe project. We're super excited about that journey and continuing to be a part of the Open Mainframe project. So the way our community works is we have a repository that represents each of the open source projects that we've ported in zOS, and we're going to go through this in a lot more detail. But everything is available on github.com/zopencommunity. Everything from the source code changes, the packages, our discussions, issues, we're open through and through. Everything is available on github.com/zopencommunity. And the zOpen community itself features a wide array of tools and projects, including our flagship tool, Git, many core utilities like Bash, curl, editors like Vim, and most recently NeoVim, security tools like OpenSSL, GPG, and much, much more. So if you're interested in learning about these projects and how to leverage them, then please check out our session that follows this. And it's going to talk about how you can take advantage of the zOpen package manager to start using these tools right away. So with open source projects, tools and libraries can be written in many different languages. For the most part, we deal with C and C++ since the foundational core set of tools are mostly written in C and C++. Nowadays, though, with modern open source projects, we're beginning to see more projects being written in Go, Rust, Python, Java. So we are starting to adopt many of these non-C and C++ projects as well. So if you know a thing or two about these projects, you can actually get started as soon as today and start contributing to the zOpen initiative. So working with open source can be complex and a little bit daunting if you're first starting out. So this slide gives you a bit of an overview of how things are structured in the zOpen community. So our tools, as I mentioned, are all held in individual repositories. When you make a commit or a change, it's usually made through a pull request, which really just formalizes the change and describes it, and then allows other maintainers to review that change. That typically, the way it works in the zOpen community is it triggers a GitHub action. And when that GitHub action is triggered, it really what it does is it tests that your change is functional. All the build continues to build successfully. The test cases all pass, and there's no regressions. And then we also have some other checks on top of that. And this is all driven through what is known as the zOpen build framework. And Haritha is going to talk about this in a little bit more detail. But at a high level, the zOpen build framework allows us to have a consistent framework across all of our tools so that we can apply the zOS patches in a consistent way, and so that we can maintain our repos in such a way that we can have automation built on top of it. So what this does is it performs a build, links in our external libraries, which we'll talk a little bit more about, and generates an executable, runs the test cases, and then at the end, ultimately packages our releases into a GitHub release. So this is really the life cycle of how the open source projects operate within the zOpen community. So what are some of the technical considerations with dealing with open source, right? When you're first starting out with open source and you would like to port a particular tool or library, there's a few things to consider. So taking licenses out of the equation, one of the key considerations, technical considerations when working with open source is the programming language. So this usually often dictates the build system as well as the build dependencies that are required. So build systems can usually vary from makefiles, which are more typical for older open source projects, to newer types of build systems like CMake, Ninja, Go Build, and more recently Meson and many others. So understanding the build system, knowing how it works is one of the first things that you usually have to undergo when porting a project to zOS. And not only that, we need to also make sure that the build system itself is available on zOS. For the most part, we've ported many of these build systems to zOS, so typically you should be good to go. And then there's the dependencies. So for example, when we first ported Git, we couldn't just start by porting the Git source code. We had to actually first port the underlying dependencies, and that included libraries like curl, zlib, OpenSSL, and many others. So in fact, in the early days, much of the work was put forth to actually creating this foundation layer, getting the libraries ported and in place so that we can build some of the more complex open source projects. And then there's also the zOS specific aspects to consider. Does it make sense for us to build all these tools in UTF-8 or ASCII mode, or should we build them in EBCDIC mode to minimize the encoding related changes? In our cases, we are actually building every open source project in the zOpen community as a ASCII mode application. And this is really just to minimize the number of changes that need to go in to these applications. It also helps with upstreaming because we're upstreaming and contributing less encoding related changes to the upstream communities. And they're willing to accept our changes because of that. And then the other question is, does the C LE runtime provide all the necessary functions? The C runtime, has in the, let's say in the last couple of decades, been a little bit slow to adapt to the new Linux APIs that are being provided through glibc or other C runtime implementations. But within the last couple of years, I would say since the onset of zOS 3.1, they've made significant progress. But still, even with that said, there are still some missing functions that we need to fill in the gap for, and that's where our zOS lib library comes in, which we're going to talk about. And finally, when we're porting these open source projects, we also need to make sure are these open source projects, do they have compilers available on zOS so that we can actually port them and compile them. For the most part, we're okay. We have the client compiler, which really helps for C and C++ projects. We have Python, Java, and Go, now available on zOS as well. But what we don't have right now is a Rust-based compiler. So we're still waiting on that before we can actually take part in porting Rust projects to zOS. Okay, so fortunately, we have what is known as the zOpen build framework, which really streamlines a lot of the porting efforts for us. So the zOpen build framework is responsible for building all of the zOpen community tools. It's driven by two things. One is the build AOV, which is essentially you can think of it as a recipe for how to build a particular project. And we're going to take you through some more detail on how this all works. And then we also have the patches. So these are the zOS enablement patches that we have yet to contribute back or upstream to the open source communities. So with this, we now have a common build framework that's able to build all of our tools. We can also add additional prereqs like zOS lib library, or in the case of Git, curl, zlib, and OpenSSL, so that rather than relying on the user to have these already pre-installed in the system, the zOpen build framework will have smarts, or it has smarts already built in to detect if these dependencies are present. And if not, it actually goes in and installs them automatically for you. And we also typically leverage the OpenXL 2.1 compiler as well as the Go compiler for zOS, reducing the number of changes significantly. Okay. Okay, so the other component that I want to talk about is the zOS lib porting library. So this library is almost exclusively used for all of our C and C++ projects. It was originally developed for Node.js on zOS. And really its aim is to implement a lot of the missing subset of functions that you would find in the Linux C runtime, which are not currently present in the C LE runtime. It also addresses a number of issues when dealing with mixed code pages, amongst other things. So again, this was originally implemented, I would say about 5 to 6 years ago for the Node.js on zOS runtime. It was open sourced, and now we're extensively using it within the zOpen community for almost all of our C and C++ projects. And here are just a couple of key examples of what the zOS lib porting library does. So just to give you a summary, when we initially started porting some of our tools, including Git, there was about, I would say, 500 lines of code that we originally added. And then once we integrated the zOS lib library, it reduced the number of changes that we needed to make to our individual ports by approximately 50%. So it's really a library aimed at filling the gap between zOS and Linux, so that you don't really have to worry about some of the more common known issues that you come across when porting. It really minimizes the number of changes that you need to consider. And here's just a couple of examples of those changes. So one is we override the copen and cpipe functions to actually tag newly created file descriptors. So by default, the C runtime doesn't actually automatically tag file descriptors. So let's say you're creating a new file and your application is built in ASCII mode, it will not actually tag that file. So what that means is that if other programs are attempting to read or do I/O on that file, and let's say it's an episodic program that's doing I/O, it will not know how to auto-convert because no tag is currently present. So we leverage LE's auto-conversion facilities considerably, and that's why we depend on file tagging all across the board. It also tags the standard out, standard error, standard in character devices. So this is really important when redirecting or piping to other episodic applications. And we also have a mode that allows you to control how untagged files are read. So we acknowledge that untagged files can be ambiguous. They can contain either episodic data, ASCII data, or potentially binary data. So we have an environment variable that is implemented through zOS lib that controls how these untagged files are read. Okay, and the other thing that we have is we put in a lot of effort into automation, which really, I think, improves our efficiency considerably. So we leverage GitHub Actions in our Jenkins CI/CD pipeline for automated builds, testing, releases, and also automated updates. So we have, what we're doing is we're taking on a project called Bump, which allows us to check for new releases for all of our ports across the board. So if Git has a new update, let's say from Git 2.48 to Git 2.49, we'll automatically get a pull request created for us, which gets triggered and then allows us to automatically update. So one of the great things about this is that it allows us to get almost day one security vulnerability fixes, and really helps with currency across the board. Okay, so now we're going to start off with a bit of a demo to give you a visual of how everything works within the zOpen community, as well as how you can get started in contributing. Okay, so let me make sure I'm sharing the right screen. Okay. Right, so I've just opened up my browser, and I've currently pointed it to zOpen.community. This is our website, our landing zone for anyone who's interested in both taking advantage of the zOpen community tools, but also for those who are interested in getting started from a contribution standpoint. So we have a couple of sections here. One is to explore and engage. And if you're curious about contributing, we do encourage you to actually try using the tools within the zOpen community. It's actually quite simple. And you can learn a little bit more about that in our upcoming session about how to leverage these tools, how to use the zOpen package manager. So we do encourage you to try that out if you are interested in contributing to the zOpen community. But in a nutshell, one of the first things that we ask contributors to do is go through a documentation, see what's currently available. So I just clicked on available tools and libraries, and you can see that we already have quite a few tools that are available in our portfolio. If there's anything here that's missing, you can let us know and start contributing today. And Greta's demo will actually take you through the process of porting a new tool, an open source tool, to zOS from step one all the way to getting it to build. Okay, the other thing I wanted to show you is our overall status. So if you click on status and then overall status, you can see that we have a number of ports at varying degrees of quality. Some of them have, actually quite a few of them have most of their test cases passing. Others require a bit more work. And you can see over here that we have our individual success rates and quality for each of the tools. So this is also one way in which you can contribute, whether it's improving the success rate for a given tool, or in some cases, we actually have not enabled testing for certain tools. And that's another area that we potentially need some help in. So for example, for Antport or Groovy or Caddy, we have yet to enable test cases. And it's either because there's something with the test framework that may be missing, or perhaps a dependency that is missing that needs to be added, or it could be that we just haven't enabled the testing, or in some cases, it could also be that we haven't actually parsed out the test cases so that they can be displayed in a unified manner, like what you can see above. So the other thing that we focus quite a bit on, so with open source, the risk of vulnerabilities is quite high. So as I mentioned before, we have automation that allows us to keep current with the open source releases for many of these projects. So we have something called currency here, which allows us to keep track of which tools have pending pull requests that update them to the latest versions. And you'll see an X next to the ones that require manual intervention. So we've tried to keep track as much as possible, but with over 200 plus tools, it's something that we need to go through one at a time. Some are more difficult than the others, and others are just a matter of potentially checking to see if everything went through and merging it in. So for example, if I click on the core utils update, you can see that all the tests have passed. And the one change that was made was to go from 9.6, 9.6 to 9.7. Okay, and so the one other thing that we've introduced this year is to track the number of patches that our community maintains. So for us, we look at the number of patches as really opportunities to upstream, right? So our end goal is to reduce the number of patches down to 0, which effectively means that we've contributed all of our changes back to the original communities. So we actually made considerable effort in the last month to reduce the number of patches. And as you can see, since 2023, we've actually, due to the fact that we continue to add more and more tools, we've increased the number of patches in terms of lines of code to about 30,000. And in the last month or so, we've reduced that by about 2,500. We're continuing to work on that to reduce the number of patches. And you may wonder, like, how we're reducing the patches. So the main way is to upstream these patches to the communities. That way, the open source communities like Git, curl, bash, they're adopting our changes. And this really helps because they can then also help maintain our changes. If there's a change that needs to be made in a similar area, they can help adapt the code. And yeah, so it also allows them to potentially detect any regressions that may come in with that code. But if it remains on our side, then it's going to take quite a bit longer for us to detect that issue and resolve it. So the aim really is to upstream as much as possible. And in some cases, it may not be possible, but so far we've seen quite a bit of success in upstreaming many of our tools from GNU-make. Many of the patches for Git have also been upstreamed. Bash, curl, Vim, and many other tools have also been upstreamed. So over here, you can also see a breakdown of the tools with the most amount of patches. And this is also one area in which you can participate. So if you're interested in working with both the zOpen community and the open source communities and want to help in upstreaming, this is one area in which you can help significantly. Okay, so now I'm going to take you back to the main page, and I'm actually going to click on the github.com zOpen community organization page. So this is effectively our organization page within github.com. And as you can see, we have a similar landing page here. If you're interested in taking a look or taking a deep dive in our repositories and what's held within them, you can click on repositories here. So our main repository is called the meta repository. And this holds the code for both our package manager as well as our documentation plus other automation. But each of the other repositories is essentially a holding ground for the ports for that given open source project. So for example, if I were to click on NeoVim port, and by the way, NeoVim is considered a successor to Vim. It supports many new features that are not currently available in Vim. And this was just recently ported as of early this year. Okay, so when I click on a particular project like NeoVim in this case, you can see that there's really two elements that are key, which I talked about earlier. One is the building MV configuration, and the other is the patches, right? So these are, again, the zOS enablement patches. This allows the project to build on zOS and also to function correctly. So you can see there's quite a few patches. These have yet to be upstreamed, obviously. But if they were upstreamed, then we would have eliminated them. And yeah, you can see, so these are just essentially diffs, which can be applied through git apply. And they're generated through a command called git diff, which checks for any changes in your given Git workspace. And each of the files represents a patch for that particular file. You can also combine multiple patches into feature types of patches. So in some cases we do that as well. But essentially, if you go through these, they're all just diffs that are applied on top of the open source community repository. Okay, so those are the patches, and those enable the tool to build successfully and also function correctly on zOS. And then there's also the build.env file. So again, this is essentially the build recipe for how to build that particular package. Now we have a lot of smarts built into the zOpen build framework, which drives how we actually build these tools. But the way it works is you essentially need a couple of inputs. So one is, where do you get the source code from for that open source project? So in this case, for NeoVim, the source code is in github.com/neovim. Right? So this is the source for NeoVim. And they may need to tell it which category. This is like a remnant of some of the zopen package manager requirements. And then the other thing that's very important is to specify which dependencies are needed by this project. So whether it's curl, CMake, or make, these are dependencies that don't exist natively on zOS, but can be obtained through the zopen community. And in some cases, like with ManDB, for example, we have up to 20 different dependencies that we needed. And the way this works is you specify these dependencies, and you run our tool called zopen build, which is from the zopen build framework, and then it will automatically obtain them if they're not currently present on your file system. And there's a ways to specify whether it's a stable build or a development build. You can also choose which compiler to use. So we typically use the client compiler for all C and C++ projects. And if there's any runtime dependencies, we also mention them here as well. So as you can see, for NeoVim, the configuration is actually quite, it's not too in-depth. There's only about 59 lines of code. In most cases, if you're building from a build system that's common, like makefiles or CMake, you typically don't need to make too much modifications. So as you can see in this case, we're only modifying the way NeoVim is built because there's additional options that we can pass in, and that's where this line comes in. But in some cases, you don't actually have to make any modifications. All right, so there's also a way to extract the test results, and that's part of why, if you recall from the other status page, why some of the tests were skipped. And that's because we have yet to add the logic to extract the test results. Okay. Okay, so one other thing I wanted to show you is the status in the status page is the usage statistics. So one of the things that we do as part of the zopen package manager is provide or enable opt-in usage analytics. So users actually have to opt in order to activate these. But once they do, these analytics actually give us quite a bit of insight into which tools are the most popular and most installed. So this gives us an idea of where to put in our efforts, because we are a fairly small team, although we have quite a few volunteers. The dedicated team is quite small, so we need to make sure that we're putting in all of our effort into the critical or important tools. And this table here gives us an idea of which tools are most widely used. Okay, so right now I'm gonna pass it off to Haritha, and Haritha actually was kind enough to record a demonstration of a lot of the things I talked about today. So I'm going to go ahead and play this video.
Hey everyone, thank you, Igor. So let us understand how do we start this development activity for porting a tool on zOS, right? So first of all, like in order to do this, we have to identify the tool which we want to port, right? So we need the source code for that tool, and we use that source code in order to port that tool. Major steps which are involved in the porting process are bootstrap, configure, build, check, and the fifth step being install, right? So these are the five main steps which are involved in a porting process. And in fact, like zOpen framework has made our life easy, where it reads just one configuration file which is called build.env, and this file tells the framework as to what are the commands or the scripts which has to be run during each of these five steps, and what are the environment variables which has to be ready during this porting process, and all of it, right? So that is what we configure in the build.env and provide that as an input to the zOpen framework. And zOpen framework just runs these, has the automation where it runs these five steps. And if it has a successful build, then it will install it as well, right? So it will, once it sees that the number of test cases which are passed in the step 4 is like, has around 8 reached 80%, 90% based on an input, then it will install this tool as well on zOS. So, but in to write this build.env file, we have automated this by using a command called generate, where you run zopen generate, and then it will, based on the questions which it prompts, we provide certain inputs, and based on that it will generate the build.env file for us, which is further leveraged by the zopen framework in order to build the tool and port this tool onto zOS, right? So basically, now I will show you how do we run the zopen generate command. This is the very first step, which is, required in order to port a tool. And then further, we once the zopen generate is complete, we run the zopen build on the generated directory structure, which also has the build.env file. And then once we run the zopen build, if this all the steps are successful, then it will install the file the tool automatically on zOS. So we will see all these like zopen generate and build, along with how do we contribute these changes back to the community if the porting is successful, right? So for now, like I was mentioning, I have identified a tool called which is used to find the location of an executable on zOS. So we do not have this currently. So I have also found the source code location for this tool, which is carlowood.github.io/which. The source code is in the tarball format here. And there is also a GitHub repository for this. And this is the GitHub repository. And it is under the GPL 3.0 license, right? But for the porting process, I will use this source code. So if I right click and say copy link to address, I would get this link, and then I would use this for the porting process, right? So let me share my terminal, and I will show you how to run this zopen generate command in order to get this directory structure and further run the build on it, right? So let me create one temporary directory called test.gse, and I'm going to go to this test.gse and run the zopen generate here. Basically, what I've done is I have installed the zopen framework on my system, and zopen framework provides me the zopen generate capability and also the zopen build capability. There's a session tomorrow which talks in detail about how do you install the zopen framework on your system from the meta repository. So I assume that you performed those steps and configured it. And with that, now I will run the zopen generate command under the test.gse directory, right? Now, what is the project name? Like we have identified, my project name is which, right? And what is the description? Which is a utility which is used to find the location of the executable on an OS, right? So that's my description. And there are many categories under which any of the tools falls. So this tool called which falls under the core tools. That's what I feel. So I've added this as a core tool. And like I was mentioning earlier, this is the GPL 3 license, right? And I've added that. And I have fetched the location of the tarball from my previous URL there. So this is the location of the tarball. And any of the tool, for it to build on any platform, it will have dependency on several other tools and also few libraries, right? Like Igor was mentioning earlier, zOS lib is one of the very important libraries. And since it is in a tarball format, we will also depend on tar and gzip, along with make and m4 macros for the build, and curl for downloading this, and sed and grep and core utils in order to leverage these core utilities, right? And sed and grep commands when during this in the scripts for this tool, right? So I'm providing these as the basic dependencies. And devline, for now, I have provided a stable build location. So I'll skip the devline related stuff. But otherwise, you can provide the Git location, which I've showed you earlier here, along with the dependencies for this dev build. Generally, Git is also one of the dependencies because we are going to clone those, right? We are going to get it from the Git repo there and clone it. So Git would also be a dependency along with the autoconf and all those auto tools also, right? Because it is from the Git repository, but I'm not providing all those. I'm skipping it for now. And since I've provided only the information related to stable build, I'm providing it as a stable build, default build line as a stable build here. And I don't see any of the runtime dependencies as of now. So there we go. The which port, we see that there's a directory called which port, which is generated. And this is the basic directory structure which is needed by the zOpen build framework, right? And majorly it depends on this build.env file, which is a configuration file where we provide the details about the stable URL, dependencies, build line, categories, and all of it. And like Igor has explained earlier, we're going to just skip this check results and get version for now, since we know what it does. So I'm going to run the zOpen build command on this which port now. zOpen build with the verbose enabled. I'm going to run this command. Sorry, there's a typo. zOpen build, right? So during the build process, first what it does is it gets all the dependent tools and libraries and then installs it so that, the build process is smooth. Further, it will also get the code from that location, what I've mentioned. It is using the curl command, and then it will untar it and then apply all the patches if there are any. For now, there are no patches here. So that's why it is going to skip that. And also the bootstrap step is also skipped because I've not provided anything in the build env for bootstrap, right? So it is continuing with the configure since it found a configure file, and then it will also build it, right? So once the configure is complete, it will, if it is successful, then it will go to the build step, which is the third step, right? And once the build is also complete, it will go to the check step. And once the check is successful, it will go to the install, right? So it will install the tool on your operating system. Now we see that the check is also completed and the install is also completed, right? So let me see if which is working fine now, right? So like I was mentioning, Meta 5 November is my root location. So which is installed here. So let's see if we can find the location of any other tool here, which curl. Wonderful. So it is giving me the location of the curl executable as well, right? So you see that it is installing to the meta file location here. So we see that which is pointing to that only. Okay, so let's see how do we contribute it back to the community, right? So I will show you that I will create a repository in my profile, and then you can do that similarly under your profile and contribute it back to the community. So this is where I go here. This is my profile. I go to my profile, I go to my repositories, and I say create a new repository, which is, I choose the owner, it is me, and which is which port, right? So let me give the description, which is an utility, which is used to find the location of an executable on an OS, right? So that's my description. I've made it public, and I'm also going to add a README for now. And then I'm going to create a repository here. There we go. We have a repository now. Now let us take the URL of this, since I've configured an SSH key. So I'm just taking the SSH one, and I'll share the terminal so that we'll see how do we, contribute this back to this. So there we go. We are in the test GSC location. I'm going to create one temporary check-in directory. I'm going to go to check-in directory, right? And let me clone this. So which port is cloned, right? Only README is there. So let me copy rest of the data from the location which was generated by zOpen, right? Which port? I'm going to copy entire thing to this current one. And I also know that actually which is a directory which is, downloaded later on during the build process. So I don't need that. And also install and log a few of the generated directories. So I'm going to remove that anyways, so that it will be regenerated again during the build process. So I don't need it now. I'm going to delete all this. So let me see the git status for now. Okay, that looks good to me. And I'll say git add all, right? And I'm going to commit it to the message saying initial changes, right? for the which tool. So this is the git commit, and then I do a git push. You see that the git push is done to the main branch. So now I'll show you in the repository as to how it looks, right? Let me refresh this. There we go. We have all the changes in the GitHub now. So this same thing you can do it under the zOpen community as well, which is like which is our zOpen community here. We will create a we will create a public repository for you, and you can push your changes here. We will review and merge it. So that's about how we port a tool and then contribute it back to the community, right? So thank you, Igor.
All right, thank you, Preetha. So if you have any questions about the porting process, let us know. I know we're running out of time, so I will continue with the last few slides. First of all, big thank you to our open source community. Thank you to all the contributors who have made this possible. If you're interested in contributing, you can get started by taking a look at our website. We have a lot of links that can help you get started. We also are part of a community in the Open Mainframe project, as well as on Discord. This is usually the place we go for real-time communication. So if you want to engage with us in real time, we encourage you to join the Systemz enthusiast Discord community. You can talk to us there, ask us any questions. We also hold periodic guild meetings every couple of months. They're typically monthly, but we actually skipped April. We're hoping to have another one in May. In this way, you can learn about the latest and greatest within the zOpen community. So what's next? We are looking to port additional tools. If you are interested in helping us out with any of these top voted tools, let us know. So everything from adding the missing subset for core utils to adding functionality that's missing in rsync, like being able to preserve file tags, or even porting new tools like FileGrind, HTOP, Gradle, and others. Let us know. Hopefully this will give you an opportunity to contribute and get started in open source today. And if you don't have access to a zOS system, or if your current access is restricted to certain types of development, then this is what the public-facing zOS access enables you to do. So this was recently just launched in the beginning of this year. It's a way for open source developers to get access to zOS for the purposes of contributing to open source. It also allows us to enable CI/CD pipelines for these open source projects so that they can target zOS. And really just gives us an ability to make zOS a first-class platform by inviting volunteers who may not necessarily have access to zOS. So this is a great way, and the link is provided here. So you can fill in the form, let us know how you would like to contribute or how you would like to use these tools in open source zOS systems so that you can start contributing today. And that concludes our presentation. So we went through an overview of how you can get started with porting open source software to zOS. If you're interested in learning more about how to leverage the tools and also how to take advantage of our zOpen package manager, our next session, we'll talk about that in more depth. Okay, and thank you very much.
Thank you, Igor. Thank you, Haritha. You guys did a great job. I actually learned something during this session, so thank you at 2 o'clock in the morning.
Nice.
Everyone, join me in giving a round of applause to both Igor and Haritha. Looks like all the questions were answered in the chat. Please don't forget to fill out your feedback forms. This is session code 4A, and we'll see you at the next session. Thank you.